In this question, we've got a box sitting on a floor with a coefficient of friction mu. A box has mass m1, and then another box, m2, is placed on top. And you're asked a few things about that. The first thing that's going to happen is that we've got our weight to start with. We've got m equals m1g. But when that second box is added, our weight is going to increase to include two components. Weight equals m1g plus m2g. Because our net downwards force has increased, that's going to have a corresponding equal and opposite increase in our reaction force, which will now equal to m1g plus m2g. And I've tried to make that arrow approximately twice as long, or the combined length of these two vector arrows. The next thing we're going to look at is the force required to accelerate. What's the difference between the force, we'll call that F1, required to accelerate only the first box on its own, and F2. So what is this ratio, F2 over F1? So we're going to start by having a look at those two forces individually. So the force required to accelerate mass 1 on its own at an acceleration of a, and this force 1 is broken into two components. You've got the forward force, there is you pushing, and the opposing force, the force of friction. So I'll call that a force of friction 1. And this F is the force that we're asked to compare. If we're looking at both blocks together, our total force that produces that acceleration So I'm going to rewrite this side of the equation, putting in our coefficient of friction instead. M1 plus M2 G. Write that a little bit smaller. And now we can rearrange and then have a look at our ratio. So let's start off by rearranging this one, equation 1, F1 is equal to you can take M1 outside the brackets. And F2 is equal to, whoops, I'll just combine that step. I'm running out of space. So now we're going to calculate our ratio, let's see, F2 over F1, and we can see that these two will cancel, M1 over M1 plus M2. And we can leave out the A plus mu G term because that's the same for both F1 and F2.